All right, hello again, class. So here we are, back to factoring. So yesterday we took a look at factoring trinomials to the form x squared plus bx plus c, where we didn't have a coefficient in front of the x squared term, or the n squared term, or the b squared term, or whatever your first term is. And today I want to take a look at what's going to happen if we do have a number in front, how it's going to affect our factoring process. It's going to make things a little bit more complicated, but not too bad, not too bad. So first, let's recap sort of what we did yesterday. We've got a polynomial right up here, z squared plus 15z plus 36. I want to factor that into two binomials, right? So we're going to start with our two binomials. And again, the fact that there is no coefficient in front of the z squared term means I'm going to have to start each one with what? I got z squared, each one better start with a z. And then I want to find two factors of 36, positive 36, that give me 15. So let's see, 36, we've got 1 and 36, right? That's not going to work. 2 and 18, that's close, but not quite. 3 and 12, oh, 3 and 12. 3 and 12, that would work perfectly. We'll place one in each. Plus 3, plus 12, and we've got our polynomial factor. Look all right so far? Okay, hopefully your z's look better than mine, because my z's kind of look like 2's, but you get the idea. All right, so now let's assume we've got a product of binomials. I want to sort of walk through our flow process again and see where each of these terms comes from. So go ahead and multiply 3 plus x plus 2 times 2x plus 5. Go ahead and do that, pause that, multiply them together, and then unpause in a second. All right, hopefully you have multiplied those two things together. And what did you get? Hopefully you used FOIL, or maybe old school, or maybe repeat distribution. And what you should have gotten was, at least initially, 6x squared plus 15x plus 4x plus 10. And then, of course, those middle terms, as quite often is the case, combine to give you a plus 19x. That should be what we get, right? Now, I want to analyze this a little bit real quick to see where each of these pieces comes from. Because if this is our trinomial, 6x squared plus 19x plus 10, and I want to try to factor that back to this original set of binomials, we got to come up with sort of a way to do that. And I tried to color code this a little bit for you. So hopefully we can see that this first term, our 6x squared, came from the 3x times the 2x, right? So this coefficient of 6 must have come from a 3 and a 2. Or it maybe could have come from a 1 and a 6, but in this case it came from 3 and 2. And this last number 10, well, that was the product of our last two terms, which are 2 and 5, or positive 2 and positive 5. And that gave us a positive 10. Okay? Now, these middle two, 15x and the 4x, those are the ones that combine to give me a 19x. But at the very least, I know that my last two terms had to come and multiply to give me 10. Our first two terms had to multiply to give me 6. And we're going to try to make the inner and outer terms sort of work out. Okay? So this is the method that is called guess and check, or trial and error, however you want to phrase it. And this is actually a method that is going to be in most textbooks. It's the most common method that people use. I don't particularly think it's the best method to use, and in a lot of cases I'm going to recommend not using it. But at least for simple polynomials, simple trinomials, it's a decent enough method. And the idea is that these first two terms have to be factors of 6. These last two have to be factors of 10, so that I got my first and last. And I'm going to guess and check. I'm going to pick some things that make 6, pick some things that make 10, and see what we can do, and see if I can get that middle term to be 19x. So I'm going to go to the next page where I do a little bit more space, and we're going to do this here. So again, the coefficient of our x squared term is 6, so I want these first two numbers to multiply to give me 6. And since I got an x squared there, I know they both need x. Okay, so at the very least I can say that's the case. And I want these last two numbers to multiply to give me a positive 4. So this is a different example than the last one, just so we can kind of see a new one. So 6x squared plus 11x plus 4. Okay. Let's pick some factors that are going to give us 6, and we'll throw an x after each. We can use 1x and 6x, or we could use 2x and 3x. I'm going to use 2x and 3x. And I'm going to start with a 2x and a 3x, one in each. And I'm going to pick a couple things that multiply to give me 4, and I want to see if I can get the middle terms to be 11x. Okay, well, let's see. 4, that's maybe either 1 and 4 or 2 and 2, right? Let's pick one. You pick one, I'll pick one. I'm going to try, let's say 2 and 2. Sound good? So I'm going to try plus 2 and a plus 2. And I'm going to move this up a little bit so we got a little bit of space to work here. Now let's try to FOIL this out. So our first terms, certainly 2x and 3x gives me 6x squared. Now my outer and inner terms, well, let's see. My outer terms are 2x times positive 2. That's a positive 4x. And our inner terms are 2 times 3x. That's positive 6x. And, well, our last terms I know are going to give me a positive 4. I'll put that positive 4 there. But what problem do we have here? If I add these middle two terms, 4x plus 6x, what do you get? We get 10x, which is really close to 11x. But close just isn't good enough here. So I know that's not going to work. So my options at this point are to change things a little bit. And I'm going to say maybe the positive 2 and the positive 2 weren't the correct values. Maybe it had to be 1 and 4. So I'm going to try that. So I'm going to erase these two here. Now it's possible that the 2x and the 3x are wrong also, but we're going to make that assumption. We'll see what's going to happen. So let's say instead of being plus 2 and plus 2, it's a plus 1 and a plus 4. So plus 1 plus 4. And now let's multiply those middle terms. Our outer terms now are 2x times 4. That gives me 8x. My inner terms are 1 times 3x. That gives me 3x. My last terms, again, give me a positive 4. And this time, if I add those middle two terms together, I get, let's see, positive 8x, positive 3x. That does give me 11x. So I know that that is the correct factoring. If I tried the 1 and 4 and the 1 and 4 still didn't work, that would tell me that the 2x and the 3x were wrong. And I'd have to go back and maybe start with 6x and 1x and go through that process. So that's kind of the tricky thing about guess and check. Using this method, especially if I have a first term that has a lot of factors, 6 isn't too bad, but 6 has a couple choices. If this first term were 24, I'm not going to want to use this method because there are so many different things to start with. Okay? So here's, even with this simple example, here are all the different things that could happen, or at least some of the things that could happen. This could be your process. You might have to try this lots and lots of times before you finally end up with the correct answer. Okay? So that's guess and check. So let's try that. Let's try that with this one here. And this one I want you to try on your own. So again, try this with guess and check. You're going to set up your binomials. And you want to pick two factors of 3x squared, put 1 in each. Pick your factors of 16, multiply your inner and outer terms, and see if you can get that value to work. All right, so go ahead and pause it and try that right now. Go ahead and pause it. Come on. Don't wait for me. Pause it. Okay. Did you get it? Let's take a look. So we're going to start with two binomials, right? So binomial, and we're going to pick some things that are going to work. Now this is an example of a case where I'm probably going to think that guess and check is a decent method because 3x squared is my product of the first terms, and I really only have one possibility, right? My possibility is, what are the two things that multiply to give me 3x squared? Hopefully you're guessing 3x and 1x. Now certainly I could do a negative 3x and a negative 1x, but that's not usually going to happen in these cases. Typically we're going to have positive first terms that give us a nice positive first term product. Good so far? All right, now I've got a positive 16 here. I'm just going to throw out 4 and 4 and see if that's going to work. Now I know these have to add up to a negative 16, the middle term, so I'm going to assume this is going to be a negative 4 and a negative 4. So negative 4, negative 4. And I want to see if that's going to work out. If we multiply these here, our first terms, 3x times 1x, is 3x squared. Our outer terms are 3x times negative 4. That would be a negative 12x. And my inner terms are negative 4 times 1x, which is negative 4x. My last terms here are negative 4 times negative 4. That's positive 16. And of course, we add our middle two terms together. Do we get negative 16x? In this case, yes, we do. So in this case, I happen to guess correctly. If the negative 4 and the negative 4 hadn't worked out, I would try a negative 2 and a negative 8 and see if that would work out. In this case, I actually did just guess those, and we actually did get it right. When you guessed the first time, did you get it right? I'm guessing probably about half of you did, and maybe half of you didn't. And that's okay. That's part of guess and check. Guess and check, you're going to guess it, you're going to try it. Sometimes you'll be right the first time, sometimes you won't. That's why I don't love the method, but the method certainly does what it needs to do. Good so far? Okay. So Let's go through a different way of doing this where I don't have to just flat out guess, okay? So I'm going to start back with our original example of 3x plus 2 and our 2x plus 5. And when we FOIL those out, again, we get 6x squared plus 15x plus 4x plus 10. Again, we combine them to get that middle term of positive 19x. Okay, now, a little bit of analysis here, okay? So this is your polynomial. This is your trinomial that you resulted from a product of two binomials. What's the product of a times c? That's my first question. Go ahead and multiply a times c. A is 6, c is 10, right? When you multiply those two together, what do you get? Unless you did computations wrong or have a broken calculator, you got 60, right? 6 times 10 is 60. Okay. Now, how about the product of the inner and outer coefficients? So going back to the inner and outer up here, our outer coefficient was 15. Our inner coefficient is 4. Go ahead and multiply those two together. What'd you get? 15 times 4 gives you 60. Huh. So the product of a times c gave you 60. And also the product of the inner and outer terms gave you 60. Okay. All right, now we're getting somewhere here. All right, so if my trinomial is a x squared plus bx plus c, I know these first two terms are going to have to multiply to be the same as the inner and outer terms. That's going to help us. Okay, I'll show you how. So first thing, we're going to start with a trinomial 8x squared plus 6x minus 5. And I'm going to find what I call the Allendale-Columbia magic number because it's AC. And AC, what does that stand for, guys? AC is Allendale-Columbia. You're right. So that's why I call this the Allendale-Columbia magic number. A times C. Up here, it was 6 times 10. That's what gave us the 60 value. Okay? Down here, 8 times negative 5 is going to give you what? Hopefully you got negative 40, right? Okay. So here's the idea. A times C is negative 40. That's awesome. All right. Now, we also know that the outer and inner terms are going to have to also multiply, in this case, to give me the same as a times c. In this case, a times c was 60. These two were 60 also. In our case, down here, our magic number is negative 40. And I want two factors of AC that are going to add up to my middle term of positive 6. Because I know my inner and outer terms are going to have that same product of negative 40. Okay? So, two things that multiply to give you negative 40 that add up to 6. Again, lots of things are going to multiply to give me negative 40. Since it's negative, one's got to be negative, one's got to be positive, right? Okay, so let's see. Well, 40 and 1, that's no good. 2 and 20 is no good. 4 and 10, well, 4 and 10 can give me 6, right? If one of them's negative. Which one's got to be negative? 10 or the 4? It's the 4, right? Okay, so we're going to say that negative 4 and positive 10. Those two things multiply to give me negative 40, and they add up to positive 6, which is my middle term. What that's going to let me do now is it's going to let me write out all four parts of FOIL. Okay, my first term is still 8x squared. My last term is still negative 5, but I'm going to take this positive 6x, and I know it must have come from a negative 4 and a negative 10. So I'm going to split those up. My 6x is going to become positive 10x and negative 4x. Again, these two, positive 10, negative 4, multiply to give you 40. So do 8 and negative 5. Okay? Look all right so far? So again, we took that middle term. I took the magic number, our Allendale-Columbia magic number. I found two factors that added up to that middle term. And then we split the middle term up into those two factors. Okay? Now I have 4 terms. And remember, when you have 4 terms, we can factor this by grouping. So I'm going to group this, and I'm going to take the first 2 and the second 2, and see if there's something I can factor out of each pair. From 8x squared plus 10x, what can we factor out? Is there a common number in both? Yeah, the number in both is what? 2, right? And how about a common variable? Is there a common variable there? Are you all nodding and saying x, Mr. Doran? I get it. Oh. So we can factor 2x out of both of these, right? We're going to do that. How about out of these second 2? Uh-oh. Do we have a number that's common? Well, not in 4 and 5. Do we have a variable that's common? Yeah, no. But I do have a negative on both, right? So at the very least, if I can't factor anything else out, I can factor out a negative 1. Even if these were positive, I could factor a positive 1 out if I wanted to. Okay? So in this case, I'm going to factor a 2x out here, a negative 1 out here, and this is what it's going to look like. So I factor a 2x out, that leaves me 4x and 5. So when I distribute this through, I get 8x squared and 10x. Over here, a negative 1 out of both is just going to change the sign. If I distribute the negative 1 back through, you get negative 4 and negative 5. And now, of course, we have that handy-dandy common binomial of 4x plus 5, and that we can factor out to the front, leaving us our 2x and our negative 1. Look all right? Good so far? Okay, let's try one like that, and then we're going to be done. I'm going to get rid of this one here. Don't worry about that. Or you can pause and try and find your own if you really want to. But we're going to do this one up here. So 3x squared minus 16x plus 16. If you follow that last example, go ahead and pause it and try. If you didn't follow that last example, then, well, maybe just be watching. But I would like you to try something on your own. Maybe try that second one on your own, okay? All right, so let's factor this by grouping, shall we? So the first thing is I'm going to want to find our Allendale-Columbia magic number. What is our Allendale-Columbia magic number? What's A? A is 3. What's C? C is 16. We're going to multiply those two things together, and we get positive 48. And now again, I want factors of positive 48 that are going to add up to our middle term, which is negative 16x. And don't worry about the x. The x is going to come from your first and last. So negative 16, let's see. Two things that give me negative 16. Well, they're going to both need to be negative, right? All right, so I'm going to get a positive 48 out of that. So let's see. 48 and 1, that's no good. 2 and 24 is no good. 3 and 16 is no good because 16 is one of them. 4 and 12 gives me 48, and those also give me 16, right? So negative 4 and negative 12. Those multiply to give you positive 48, and they add up to negative 16. So we're going to split that middle term up, okay? So I'm going to bring that over here. First term you don't touch, 3x squared. Our negative 16x now becomes negative 4x and negative 12x. Our last terms are going to be 16. Now, does it matter where we put the negative 4 and the negative 12 in this product here? No, not really. Some of you probably wanted to put the negative 12x at the beginning so that it combines with the 3, because 3 goes into 3 and 3 goes into 12. And that's certainly fine. There's nothing wrong with doing that. If you did that, that is perfectly fine. Okay? In this case, this is the way I ordered it, and so that's what I'm going to stick with. But either way would have been perfectly fine. And either way, I'm going to be able to factor this by grouping. So the first two, here's the second two. From the first two, what can I factor out? The only thing common there in my example is going to be x. So I'm going to factor that out. That will leave me a 3x and a minus 4. Out of the second pair, I'm going to factor out, well, let's see, I've got a 4 that goes into both, right? And if I just take a 4 out, let me try that for a second. If I just take a positive 4 out, that would leave me a negative 3x, and a positive 4. And if I pair my two binomials, well, they're almost the same, but the signs are wrong. So that's usually a dead giveaway that I need to take a negative out. And generally, if your first term is negative, take a negative out also. So I'm going to get rid of this here. And we're going to try a negative 4. A negative 4 divided out leaves me positive 3x. And it leaves me negative 4. And that is now going to give me that nice common binomial on both. That binomial I can bring to the front. 3x minus 4. And that's going to leave us in parentheses x minus 4. And that is going to be our factor formula. We check that real quick. 3x times x is 3x squared. That's right there. Outer terms are negative 12x. Inner terms are negative 4x. Those add up to negative 16x. And negative 4 give me positive 16. Look all right. That's our common binomial. That is our set of binomials that multiply to give me 3x squared minus 16x plus 16. We've just factored it. Excellent job, everybody. Way to go. I will see you guys later.